about first-order kinetics? So you might be wondering, oh my gosh, sir, paano nagkaganyan ang formula? Bakit ganito itsura niyan? LNC, negative KT plus LNC sub 0. Bakit may LN? Okay, so first things first nga pala, class, ha? LN stands for natural log. Okay? Natural log. Okay? Natural log kasi, class, is an expression, or it's a mathematical expression, class, often used to indicate growth, okay, per unit time. Kumbaga, madalas kasi ginagamit kasi ang natural log pag nagde-determine ka ng, say for example, growth ng bacteria after a certain period of time. O di kaya, pagdami ng pera mo, pwede rin yun. Okay, kung nag-invest ka at this, ito yung interest rate niya every year, okay, ginagamit ka sa natural logarithm to determine, halimbawa, kung constant ang growth rate na ganito, magkano ang magiging pera mo after 10 years. Ganyan-ganyan. Okay, ginagamit yung natural log. So basically, class, for any computation, linear computations, okay, that will require you to predict growth after a certain period of time, okay, ginagamit na siya, class, na natural log to express that. Okay? Now, class, growth can either be positive or negative. What do I mean by this? Mas namin positive growth, ibig sabihin, tumataas yung initial numbers. Okay, from 0 to kung saan man. Pataas yun. Pag negative growth naman, class, per unit of time, ibig sabihin, nag-start ka sa mataas, then bumababa unti-unti. Okay? Now, class, in our case, of course, here in pharmacokinetics and pharmacodynamics, pharmacokinetics, okay, ang titingnan dito would be negative growth. So, technically, nababawasan yung concentration ng gamot as time goes by because it undergoes elimination. So, kung KE yan, class, that's negative growth. That's why ang slope natin may negative sign. Kung yan, class, ay KA, absorption rate constant, ang K natin dyan, class, ang KA natin, positive sign. Kasi nag-grow yung numbers na yon. Alright? So, are we clear? Okay. Now, class, bakit natin nilagyan ng LNC? LNC dito. Okay, so, remember, class, balikan natin, ha? Pag nag-plot tayo sa semi-log, sulat natin. Okay? Ibig sabihin, pag, kunwari straight line yan, ha? Pag straight line yan, that's a first order process. Okay? Now, class, any data, ano yung mga data na nasa y-axis natin? We have the C, the concentration. And then on the x-axis, we have your time. Now, class, in a semi-log, sabi natin, may logarithmic expression lagi sa y-axis. Okay? So, in this case, class, instead the log, kasi pwede rin naman tayo gumamit ng log, pero mako-convert pa kasi tayo ng, i-divide na natin yung data dyan by 2.303. So, wag na yun. Diretso na agad natin sa LN. LN pa rin naman is a logarithmic expression. Tawag nga na sa kanya is natural log. Okay, again, natural logs, class, are logarithmic expression used to express growth for a given unit of time. Can be positive growth or negative growth. So, LN to. Pata natin, gawin natin LNC. So, meaning, class, so initially, sabi natin, y equals mx plus b. Ito ay sa graphing paper. Yung cross-sectional. Okay? Cross-sectional graphing paper. Sabi natin, ang kaparehas niyan would be yung zero order, which is Cp equals negative Ke times T multiplied to T plus C sub 0. Okay? And this is zero order. Now, ano namang pinagkaiba ng cross-sectional graphing paper sa isang semi-log? Ang pinagkaiba lang naman nila, class, lahat ng data sa y-axis ng semi-log may logarithmic, follows the logarithmic scale or follows a logarithmic expression. So it's only proper, class, to put logarithmic expressions, okay, on data found in the y-axis for the first order process. So, ang plasma concentration, nasa y-axis ba yan? So, nasa y-axis yan, lagyan natin ng logarithmic expression, ln Cp. Okay? Equals, ang slope. Nasa y-axis ba to? So, hindi. Kasi yun yung steepness ng isang line. So, how steep a line is. So, therefore, wag natin papansinin. So, negative Ke. What about time? Nasa y-axis? Wala. So, wala tayong gagawin. as is yan, t. So plus, ang c sub 0, nasa y-axis ba to? Yes, ito siya. Nandito yan, nasa y-axis yung c sub 0. So therefore, lalagyan natin siya ng logarithmic expression ln c sub 0. And voila! Ano nang na-form ko na? Formula. This is already the formula for first order. Okay? Using natural log. Now class, ito yung sinabi ko sa inyo kanina. Pwede mo tayo gumamit ng log, pero you have to divide your data by 2.3. 303 to eh. 2.3. So it complicates the situation. So gumamit lang tayo ng natural log. So are we clear? Now, you might be wondering, sir, how did you get this one? How did I get this? Okay? Okay, para mas simple nga naman yung equation ko. So, diretso na ako C. Concentration agad. Hindi ko na kailangan pasin yung Ln. Magawa tayo ng bagong color. Okay, so how did I get this one, class? So, after getting the equation na Ln Cp equals negative Kt plus Ln sub 0. Okay? Medyo nagko-complicate kasi yung presence of natural log here. So, pwede natin tanggalin to. Now, class, what's the opposite of natural log? Diba ang log may anti-log? Okay, ang log may anti-log. Ang natural log, class, meron siyang natural number. Tinatawag natin. Or Euler's number. Okay, the Euler's number, class, actually, ang spelling is Euler's number. Pero ang pronunciation daw is Euler's number. Okay? The Euler's number, class, or let's just call it the natural number. Okay, o sige, gawin natin mas simple. The base of the natural log. Mas simple ba yun? Okay, yung opposite ng natural log, which is called the base of natural log, also known as the Euler's number, also known as the natural number. Okay, ang opposite yan, class, is E. Euler's number. Di ba sabi, pag nagtatanggal tayo ng log, di ba? Pag nagtatranspose tayo ng formula, ginagamit natin is anti-log. Okay, class, I'm assuming marunong na kayo mag-transpose ng formula, okay? I'm entering this discussion with the assumption that you guys know how to transpose formulas. Alright? Okay. So, I do hope nasanay na kayo mag-transpose ng formulas. Okay? Kasi tuturo ko lang sa inyo dito paano mag-transpose using the natural log. Okay? Okay. So, now, class, paano ko makuha ang E? Press nyo, Shift LN sa calculator ninyo. Okay? If you press Shift LN, you'll get E. Right? That E, class, is called the Euler's number. Okay, or the tawag dito, natural number. Also known as the base of the natural log. So siya yung opposite ng natural log. So therefore, class, multiplying both sides of the equation by the Euler's number, which is the opposite of natural log. So magka-cancel yung natural log dito. Cancel, cancel. Now, dahil ito ay wala tong natural log, kakabitan ko to ngayon ng E. Now, class, please take note. Ang Euler's number, class, is a base, tapos raised to. Okay? Magiging exponential yung kakabitan, magiging exponent yung kakabitan niyang data or number. So therefore, kasi ang lalabas dyan would be Cp equals E raised to negative Kt. Raised to negative Kt. Now, class, this time, it will no longer be plus. This is not going to be plus. Magiging positive number na yung C sub 0. Kasi ang gagawin dyan is imumultiply natin ngayon yung C sub 0. Kasi tinanggal ko yung logarithmic expression niya dito. So technically, class, pag tinanggal ko yan, hindi na yan addition sign. Nagiging sign yan as plus. Positive siya. Positive number. It's a positive number. Okay? So ganito ngayon na magiging itsura nito. So now, class, just trying to make it clean, trying to make it look clean, baliktarin ko lang to. So ang nangyayari is Cp equals C sub 0 times E raised to negative Kt. So are we clear? So are we good? Ito ngayon yung formula na yun. And this formula simply came from this formula here. Tinranspose ko lang. Okay? It was just transposed. Alright? Pero what do I want to point out here, class? Okay? Saan nang galing ang formula for zero-order kinetics and first-order kinetics? Simple lang. Nanggaling lang yan, class, sa formula ng isang straight line. Which is y equals mx plus b. Okay, kasi ang pinagkaiba lang naman kasi ng zero order sa first order is saan siya straight. Okay? Sa ang graphing paper siya straight. Kasi kung cross-sectional graphing paper yon, zero order yon. So, gagamitin ko lang dyan is y equals mx plus b. Ang first order naman, dahil straight line siya sa semi-log, wherein ang y-axis contains a logarithmic expression or the logarithmic scale. So therefore, the data on the y-axis must have logarithmic expression. Kaya lahat ng data na sa y-axis, kung gagawa ko ng first order na equation, lalagyan ko ng logarithmic expression, which is the natural log. Okay? Okay, I hope that makes sense. Alright? If not, class, pwede nyo ulit-ulitin yung video na to. Nag-record tayo? Yes, nag-record tayo. Okay, ulit-ulitin nyo lang to para hanggang sa magets. Okay? Or kung hindi talaga, you can always ask me. Alright? Okay, so again, class, this is the formula for dito, first order process naman. So between the two, zero order versus first order, sino mas madali? Siyempre zero order. Okay? For first order, medyo technical yung process na to. And it's important, class, you understand how to compute for this because, okay, because majority of our drugs follow first order process first. Okay? Magiging zero order lang naman yun kapag na-reach ang saturation point. And for 90% of our drugs, malayo-layo pa yung saturation point niya. Okay? Okay, so here it is. Now, sabi nga natin, class, first order reaction is a linear process wherein as you increase the concentration, rate of elimination also increases. Okay, so the rate of elimination is proportional to drug concentration. Okay, so the elimination process are not yet saturated. Okay, and can adapt the needs of the body to reduce accumulation of the drug. But however, class, again, okay, after a certain concentration is reached, okay, drug process will most likely reach the saturation point. At pag na-reach ang saturation point na yon, it becomes a zero order process na. Right? Okay. So again, ang first order process, straight line sa semi-log. Here. Logarithmic y-axis. In a linear y-axis, ano yung itsura niya? Mukha siyang curve. Siyempre, mahirap naman mag-compute pag curve. So dito ay sa straight line. Kasi pag straight line, y equals mx plus b lang ang equation ko. Alright? Okay. So let's do this one, class. Allow me again to answer this one. Allow me first to answer this. Okay? An ophthalmic solution of a mydriatic drug at 5 milligrams per ml exhibits first order degradation, first order reaction, with a K of 0.00005 per day. Now, class, notice nga pala, for first order process, class, ang units ng K, before I forget, baka makalimutan ko ito mamaya, KE or K will always be 0.01 per hour. Okay? Walang unit ito. Bakit? Kasi, class, this is actually representing a percentage, a part of a drug. So, ibig sabihin, class, at whatever concentration, okay, at whatever concentration, class, ang rate of elimination would be, the drug will be eliminated at 0.01 parts of that drug will be eliminated every hour. I can actually convert this to percentage. How? Multiply it to 100. So 0.01, multiply mo lang by 100, class, you get 1%. So meaning, using KE ito, meaning, class, 10% of the drug is eliminated every hour. Okay? 10% of the drug will be eliminated every hour. Are we clear? So in this case, so 1, 2. So 0.005% of the drug is eliminated every day. So ganun kabagal yung elimination niya. Okay, so hindi mabilis yung elimination. So are we clear? Okay. This is 1% lang, but 10% sinulat ko. That's just 1%. Okay? So just multiply by 100. Ganun lang yun. So kaya wala siyang unit dito, class. Walang unit yung numerator. Because it refers to parts. Okay? So parts, percentage, ibig sabihin. Okay? Okay. So again, initial concentration natin. So ito, compute tayo ngayon. So what's the given? So we have an initial concentration of the C sub 0. Ito pa nga pala, class, baka makalimutan ko rin. C sub 0 is also known as the plasma concentration at 0 time. It's also called the initial concentration. Okay? Initial concentration. Kasi yun yung pinaka-first concentration na meron ka dapat. Okay? In any plasma level time curve. C sub 0 is very important. Okay? The concentration at 0 time. Okay, you need to always determine this one. Maliwanag? Okay, so in this case, class, given ang initial plasma concentration natin, so an ophthalmic solution at 5 milligram per ml. Okay, it follows a first order process. The rate of elimination is 0.12345 per day. So ang question, class, is how much of the drug will remain after 120 days? So T equals 120 days. Okay? So ang required ko dito, class, what I need to compute for is what is the remaining plasma concentration after 120 days? CP 120. Okay? Now, lahat ba ng units cancelable? Mukha naman. So let's proceed now to the solution. Okay? So CP equals CO times E negative KT. So what's my C sub 0? That's 5 milligrams per ml. Multiplied to the base of the natural log, or the Euler's number, right? So negative 0.00005 per day, open and close parenthesis, times 120 days. Okay? Tapos bibigyan ko kayo ng teknik, ha. Pag nagko-compute kayo nito, class, unahin nyo muna yung E negative KT. Right? Part natin yung kulay lang. Okay? Unahin nyo muna yung compute to. Lagi nyo unahin compute to. Okay? Kasi kung ano makuha mong sagot dito, i-multiply lang natin sa C sub 0. Okay? We're going to i-multiply lang natin doon. Balik tayo sa pula. Okay. So equals, so 5 milligrams per liter, per ml, sorry, times, okay. So class, shift ln. So that would be negative 0.00005 times 120, close. Ang lalabas dapat dyan, class, is 0.9940. Did you guys get the same number? Did you guys got the same number?
Yes po.
Okay, good. Sa mga basta alam yung gamitin ng calculator nyo, wala tayong problema. Okay? So, in my case, I don't know kung nakikita nyo. Hindi na makikita pala. Okay, kasi yung calculator ko, diretso ko lang input. Okay, so yun yung maganda doon. Anyway, so I got this now. Ano na lang gagawin ko? Normally, class up to 4 decimal places. Okay? Gamitin nyo hanggang 4 decimal places. Pero yung final answer, 2 decimals lang. Okay? So, this answer times 5, you get 4.97. Ayan na tayo. 2 decimal lang nga, sabi ko. Milligram per ml. So, did we get the same answer? So, mukha naman pareho sila. Okay? So, are we clear? Okay.
Yes po.
Alright. Sige, class. Gawin natin medyo, konting lang naman. Gawin natin medyo, konting technical. Okay? Using the same formula, class. Using the same formula, let's transpose it. Okay? Kunin natin, say for example, I want the formula for time. T. Okay? T. Gusto ko makita kung ano yung formula for T. Or K, na lang pala K, para mas mas bongga. Kasi sabi ko nga sa inyo, di ba, importanteng ma-determine lagi ang K. Okay? So, balik tayo dito, class, para mas mabilis ang transposition ko. Babalik ko lang siya sa dati niya. LNCP equals, para wala na yung E. Negative K times T plus ln C sub 0. Okay, alam niyo na kung saan nanggaling to, right? Okay, so hindi ko na-explain kung paano ko nakuha to. Okay? Now, class, gusto kong kunin, gusto kong kunin dito, class, ang formula for K. So, anong gagawin ko? So, to simplify this, first and foremost, I'm going to transpose this. Lipat ko muna si ln sub 0 sa kabila. Okay, ln C sub 0. So, reduce ln C sub 0, negative ln C sub 0, para ma-cancel out ito. Matanggal yan. So, mangyayari is ln CP minus ln sub 0, C sub 0, okay, equals negative K dot T. Okay? Now, class, para makuha ko si K lang, ma-isolate ko si K, anong gagawin natin? Divide both sides of the equation by T. So, 1 over T, 1 over T. Okay? So, cancel out ang T dito. So, mangyayari would be ln Cp minus ln C sub 0 over T equals negative K. Okay? Siyempre, hindi naman pwedeng negative K yung value ko. Nakita nyo naman dito, K natin is always a absolute value. It's a positive value. So, anong gagawin natin? Multiply both sides of the equation by negative 1. Okay? So, I hope I'm making sense. Okay, yung transposition process ko dito. Alright? So, negative 1 para maging positive ito. So, mangyayari dyan would be negative ln Cp plus ln C sub 0 over T equals K. So, rearrange ko lang ha. Would be K equals ln C sub 0 minus ln Cp over T. So, are we clear? Very good. Okay, so now class, I have the formula to determine my rate of elimination. The rate of elimination is simply, okay, simply using the initial plasma concentration minus any concentration at any given time. Okay? Kung ano yung concentration na yun at that given time. Now, if I want to compute for T, so baliktarin ko lang yung posisyon ng K at saka ng T. So, ang formula for T would simply be T equals ln C sub 0 minus ln Cp over K. Amazing, isn't it? Okay? So are we clear? So that's how I transpose the formula, class. Now, of course, you may have your own way of transposing the formula. So no problem. Sabi nga nila, there are so many ways to skin a cat. Okay? So you can use your own, class. I'm just presenting how I transpose the formula. All right? Kasi again, ang importante sa akin dito, class, maintindihan niyo yung foundation. Okay? Maintindihan niyo kung paano natin na-derive ang formula and the relation of the parameters found in the formula. Okay? Yun lang ang importante sa akin dito. Okay? Okay. So in general, class, so elimination kinetics, sabi nga natin, class, the concentration, so in elimination kinetics, for the curve in the log plasma concentration versus time plot, after IV bolus dosing, okay, first order is considered to be linear, zero order is non-linear, kasi it's called the saturation kinetics. Okay, so relationship between elimination rate and drug concentration. For first order, elimination rate is proportional to drug concentration. So meaning, it's concentration dependent. The rate of elimination is concentration dependent. Okay. Well, on the other hand, for zero order kinetics, it's concentration independent. Okay, it's going to be concentration independent. Right? So kasi the elimination rate saturates with higher drug concentration. So meaning, the elimination rate constant stays the same. The elimination rate stays the same. So term in clinical pharmacology called linear kinetics, non-linear kinetics, 95% of the drugs follows linear kinetics, while for zero order, only 5%. Now, please take note, lahat naman ng gamot will start at linear or first order process. Ulitin ko lang, all drugs will start as a linear process. The only difference is, some drugs achieve their saturation point earlier, such as ethanol. Okay? Or they achieve their saturation point is very near to their effective concentrations. Okay?